Okay, I think it's about time, so we can maybe get started. So this is an official IETF meeting. It's the COSE meeting. As you know, it's virtual meeting that's using the Bangkok time zone, and that's where the picture was taken from. So as an official IETF meeting, the not well applies. Uh, please make yourself familiar with it before uh, saying anything or writing comments, etc. Please, if you are not familiar with it, read it right now. So this is the agenda for today. We will start with some administrativia, then we will go through the document statuses, and then go to our rechartering, the counter signatures document, and the certificate compression. Is there any bashing of this agenda? I'll take that as a no. So the document status, we have a few documents that are waiting for edits. Otherwise, they are in IESG evaluation. Those are namely the 8152 bis document and the X509 document. On my side for the X509 document, there are a few more things I need to look at, and then I'll be able to publish a new revision of the document. So I hope this to happen in the next 1-2 weeks at the most. And we have 2 documents that are waiting, that have missing references. Those are the 5182, 8152 bis aux and the hash aux document. And we have the counter signed document that we are going to that is going to be presented separately. Maybe Karsten doesn't hear me, it seems. Okay, it seems that people have some audio issues, and I will take this moment then while waiting maybe for them to reconnect, to also ask if people would volunteer for helping with Jabber and with the minutes. We will be monitoring this with Matthew as well, but please do help with those items. Okay, then I think we can continue with the slides. So about the chartering, this is a short summary of what we have been discussing over the last few meetings. So hopefully it's not any surprise for anyone. We are going to review and accept new algorithms, for example, coming from CFRG, and maybe some others, but it will be much harder to evaluate them. And we would be working on certificate compression, either from direct mapping from X509 certificates, or as we call it, CBOR optimized, where the signature is computed on the CBOR structure directly. Okay, so yes, there is a pull request that should be making some improvements on the language of the charter, but are there any points that you would like to discuss now about the proposed new charter? Anything at all? It seems that everyone is happy with the proposed charter. So if you have any new comments, of course, feel free to raise them in the mailing list. Otherwise, we will continue with this. Okay, and with that, we can move to the counter signatures. And Russ, please join the queue.
Okay, can you hear me?
Yes.
Good. Okay, next slide, please. So the first thing is, this is Jim Schaad's work. He deserves all the credit for it, and I agreed to serve as the document editor since Jim passed. Mostly, I think what needs done is to help with the approval and publication processes, but Jim deserves all the credit for the technical content, and so I intend that my name be removed from the document when right before it's published as an RFC. Next slide, please. At this point, the body of the document is done, but the examples, Jim envisioned 5, 2 of which he did, and 3 of which are just placeholders. Next slide, please. It's the code that Jim used to make those examples is available in GitHub. I don't know if anyone is interested in helping to produce the other 3 examples. If so, please reach out to me and we can work together to make that happen. If not, we can remove those placeholders and be ready for working group last call. Totally up to whether people think they have the time and interest to work on producing those 3 other examples. That's my last slide, so that's where we stand. Is there any discussion?
Okay, so I see in Jabber that Michael is saying he would love to have the time to help, but maybe he wouldn't. So yes, for now he seems to be okay with removing the placeholders. Yes.
It's interesting that Michael was also the one who said, without working through one of the examples, he didn't understand the body of the document. So I take Michael's comment to mean that the two examples that are there are enough to get that understanding.
Okay. So.
All right. So if that's the direction, or if no one is willing to help make those, I will be glad to remove those three empty sections and post it. I'll do that promptly.
Okay. Thank you. Okay. Moving forward to the certificate compression. John.
So sorry, yeah. Working with Göran to get the slide numbers and correct aspect ratio on this presentation, but I guess we go with this. So we have done quite. We had done quite a lot and made a 02 version incorporating some of the comments, and then I had more time and made a 03 version incorporating, trying to address basically all the comments that was received both during the summer from Henk and Russ and Ilari, and also the last weeks from, or a month ago or something, from Jim. Can move on. This is quite a lot of slide trying to describe the whole, quite a lot. We don't have time to discuss everything. Was going to present the changes, the high level, and then go to things I think needed to discuss. So first high level, can move on. So I think first, this is quite early, it's not adopted, it's not even in the charter yet. So I think to be able to decide on to discuss detailed encoding, we need first what the scope is. And the first scope, the scope of the authors, how this began, was to create a CBOR encoding of a very small, or not very small, but a subset of RFC 7925. Then it grew to the whole of RFC 7925, and then people started wanting IEEE and generalized time and so on. So this scope in number of what should be encoded has grown. And so at this point, we believe that the best way forward is to create a CBOR encoding of a quite large subset of 5280, basically what is in active use, at least among for the use cases that would have any relation to COSE. And what we have done the last month is to try to make sure that we can do this while still achieving extremely high compression or encoding for very constrained certificates, for example 7925, and we believe that's possible. So we don't think these contradict each other. We can support very much of 5280 and still achieve 138, 140 byte compression of very constrained OT certificates. Any comments on this? Otherwise, we can move on. Next slide. So the scope that has been discussed, and I guess we will discuss more in the charter, is to do compression of existing 509 site and then also natively signed certs. And basically, we natively signed search you get basically for free. It's a very small addition to the specification. I don't think that has really been discussed, but I think the proposal is to only support their encoded certificates. As you can see in this list, there's a lot of other encodings. And let's see. And the proposal is to do encodings for actively used parts of RFC 5280, not all of it. But I think in some cases, making a choice affects how much you can save in compression encoding, and sometimes it does not. So it's a bit case to case. The suggestion is to differentiate encoding in the specification from profiling. Profiling could be done in other documents like 795, but I think we probably want some section or appendix in the document documenting how you achieve very small sizes, which might refer to other drafts. Next slide. This is a very high level of the current form thing. High level changes is that the things in red here are removed from the there encoded. It's duplicated signal algorithms, and then the issuer unique and subject unique IDs. Current suggestion is to not support this. They seem to be seldom used. Green here is a new field, which is the CBORD certificate type, used right now to differentiate between compressed DER certificate and a natively signed. And then the suggestion is to split up two of the fields into two items to not have to encode them as an array, which save some bytes and may or may not make the thing easier to read. Any comments? Otherwise, we move on. So, a list of changes. So, there's two updates. One was submitted 2 weeks ago, and the 03 was submitted this morning. The changes has been communicated in the past weeks. So the encoding of issuer and subject is completely rewritten as suggested by people on the list during summer. They can now encode most RFC 5280 subject and issues. They currently only printable string and UTF-8 is supported, and these are the thing RFC 528 says that you must use these for new certificates. Then the algorithms are made explicit. Before there was default algorithms. Now they are made explicit, and this increases encoding with 2 bytes, but we think it's worth it to have them explicit and not having optional value that might or not exist. Extensions move to a separate paragraph that's suggested by Jim. The CDDL is not duplicated anymore. Then a new section of compliant requirements detailing what you need to implement of this draft, or maybe say that you don't need to implement. Very little is mandatory to implement. This is to do to write. 02 to 03 is added generalized time as suggested by Jim to support dates between 2050. This is one thing that moves this draft to support more than 7925. Then the TLS registry, it was previously suggested to do this as a TLS compression. Ilari suggested that this is more a type, so we have updated this document to do that. This should be coordinated with the TLS working group in the future. Added support for a lot more algorithms. This is just Ayana registrations. Then a lot of more. I implemented large part of the draft, which made me add a lot more stricter text on regarding parts of encoding to make this implementable, hopefully in an interoperable way. Next slide. Try to reduce the number of ints. Henk commented that he did not like the large number of negative ints, but I think they are very efficient for the encoding, so they are not gone, but they are fewer. Then the title is updated based on a comment from Jim, and Karsten just commented on the list that we should change the file name also. I agree. Then abstract and intro was updated so it's up to date with the rest of the document. Added text on what is not supported in 5280. Added support for raw relative OIDs for algorithms and extensions, so you can encode this as a their encoded string. Can discuss whether that should be done or not. It's added now to show that it's possible. More info. Then the CDDL is updated to follow the recommendations in RFC 8742. That's an array and states that it's a CBOR sequence. Can be, Henk has suggested that maybe it's better to add this to do array anyway. It adds 1 byte, but it might have benefits in understanding and maybe to use CDL parsers. I think 138 or 139 bytes does not really matter for this document. So if it has benefits, I think we can or should do that. Fixed, so an empty subject can be encoded. I think that was a comment from somebody on the list this summer. The extension encoding is completely rewritten. It was very 7925 specific. It also had several problems, some errors. It was not well defined. So that has, hopefully the new is well defined and support much more. Then in an effort to support much larger part of 5280, added a lot of Ayana registrations for extensions, extended key extensions, subject alt names. More specific encoding. And as an example now that this can compress quite general certificates, an example encoding of the tools IETF org certificate was added. And acknowledgement. And now Russ is in the queue.
I'm just a little bit confused why you need relative void. Nothing in 5280 uses a relative void. Where do you see it coming in?
It was in to support extensions. When I parsed a lot of certificates, I saw that it pops up a lot of extensions. And for example, US government, I saw there's a lot of private extensions that probably nobody else uses. So my understanding of a relative void is that you don't have you just skip the 06 and the size, and it's the rest. Or have I misunderstood relative voids?
So relativoid is an ASN1 type of its own,
Okay.
and you have to know the base that you're adding the transmitted parts. Basically, there's an assumed prefix. You transmit the suffix. If you don't know the prefix, you can't create it.
Okay, yeah, that was not the intention. And I think some of the web pages I used for information used the incorrect term.
Okay.
Yeah. So the idea here was only to skip the 06, their encoding for a OID, and the size, because these are
Sure,
given
that
anyway,
makes sense. Because you could figure the rest out from without that.
Yeah.
Yep.
But good.
Which is
Then we should
different than
change
what
the
you
term.
just said. The problem is what relativoid means to people who know what ASN1 is.
Yeah.
Yeah.
Then the terminology should be changed. Yeah. Good.
Okay. What you said makes sense.
Good. How much time do we have left for this presentation? Any?
Well, as no one objected to the agenda, I think we can use pretty much all the rest of the time. I mean, if anyone has problems with that, please raise them, but otherwise, yes.
Okay, yeah, then we can go into talking more about issues or more details. Is there any more comments on the high level aspects, or all the changes will be discussed in more details, I think, later in the slides, or some of them. No. Okay, let's next slide then. So a more low-level discussion about the details. I think here is nothing new. This is just a summary. Version is assumed to be 03. Issuer unique ID and subject unique ID is not supported. And the draft adds a CBER certificate type that currently used to difference between a compressed and a natively signed certificate. And of course, it could be used for other things in the future. Next slide. So serial number, signature value, there was some discussion in the summer about serial number, whether it should be encoded as an int or a byte. Encoding is as a CBOR integer does not really work, because then you can only support very short serial numbers. CBOR ints also comes in discrete sizes, 8, 16, 32, and 64. So it's not efficient encoded. So therefore the suggestion is to encode it as a byte. Was recently a comment on the list from Karsten that says that this should be specified as an unwrapped big num. That seems to, or a big uint. That seems to make a lot of sense. My feeling is that that's already what the draft is doing on a low level, and Karsten's suggestions would probably mean that the CDDL is changed. Maybe Karsten wants to elaborate on this.
Yeah, I haven't checked the CDDL, but what I wanted to avoid is that we have remnants of weird DER sign bit handling, which are always a bad thing when you have hashes or public keys and things like that, because they might happen to have their topmost bit set, and then you run into the DER signed integer trap. And I would like to keep us free of that trap.
Yeah, the specification, right? After a comment from Jim, the specifications now say that you always remove this zero sign bit if present. So I think on a low level, I think the draft is doing what you suggest basically, but of course it does not use any big unwrap big num terminology. Maybe you can. It would be very good if you could. Maybe you can come with some complete suggestion how to change the this to big num or big uint or so. I think it sounds like a good idea. Then signature value. So the previous specification did not really did just say that you removed unnecessary field and padding, which is not really enough specification. So has added a lot of things, basically stating that for in general, you just take the der encoded value. ECDSA is specially treated, and they are then the encoding is a concatenation of two integers padded to the same length, where the length is given by this formula. And it was updated after a comment from René that it should not say curve order, but the size of the largest prime order subgroup. It also gives explicit value for the NIST P curves, which is 32, 48, and 66. Next slide, unless there are any comments. So, subject public key. So this is split into two fields, where one is an int specifying the algorithm, and for some of the algorithms also the curve. In red text here, support point compressed X509 search. While after submitting this presentation, we realized that this could be supported quite easily without increasing the size. So that is actually supported in the 03 version by using some other values on the octet. So what is added, 04 is the value for uncompressed in the der encoded certificate, and 2 and 3 are used for compressed. So this in the CBOR encoding we use 2 and 3 now for something that was uncompressed in the certificate, and minus 2 and 3 for if it was already compressed in the certificate. Then signature algorithm, this duplicate signature algorithm is removed. Then signature algorithms, it's in general, these are in the certificates. This is an OID plus a parameter which is of type any. Many or most algorithms omit parameters. Some exceptions are RSA encryption public keys and signatures, PKCS 1.5. They have parameters equals null. The draft now states that, and you just treat them as they are not there, and then you have to put back the null. Of used or the PSS algorithms and ECC public keys, they do have parameters. I don't know how well used PSS, or it's some of the PSS. The PSS with SHA-2 is using parameters. PSS with SHA-3 is not. ECC public keys have parameters where you can specify an arbitrary elliptic curve, or they use a parameter which is a named curve. So the suggestion in the draft is to not support PSS with SHA-2 and only support ECC public keys with named curves, and then encode the named curve in the integer. Also added a relative, or it's not a relative OID, support for raw OID, so you can support keys, public key size that have not been registered. I think maybe next slide is a continuation of this slide, so we can probably go to next. And here is, so in the last versions we made tables with supported algorithms and basically looked at all the algorithms without parameters that could potentially be used, and also like future things like hash-based signatures that have registrations but don't know if they're any use in practice. Should also probably differentiate between 1 and 2 byte identifiers, so that things that are used for constrained IoT and are actually used get 1 byte and the rest get 2 byte identifiers. And 255 and Weierstrass coordinate should probably be added in the future. And as a comment from Carsten this summer, SHA-1 is needed in root certificates, which is self-signed, so the signature doesn't really matter if it's weak there. Are there any comments which algorithms to support? Is the assumptions made here sound? Do we need to support any more algorithms with parameters? I think that could be done by just adding that you identify it with an integer or an array. Do we need to support, I think, PSS with SHA-2 and elliptic curve with arbitrary coordinates? I think these are the one. And do we see any future algorithms having parameter? The current trend seems to be in PKIX to not use any parameters and encode everything in the OID.
Yeah, there's a comment from Olle here on, maybe I want to take it himself, but it's about Ayana procedures for 1 versus 2 byte decisions for new registrations in the future.
Yeah, if for this draft I have added that. So there are for these are new registers for the CBOR certificate created by the CBOR certificate draft, and for I think the current what I suggestion now is that 1 byte require IETF action, I think, and or standard action, and 2 byte require just expert review. That's good. Okay, if there's no more comments, let's move on. So it's your subject. So there was quite a lot of comments from, I think, Hilary, Henk, maybe Russ or Jim also, about issue and subject. Early versions of this draft had a very strict profiling, which is where it assumed extremely much about the subject and issuer. And there was especially comment about the issue that we cannot really make such strict assumption. The current draft tries to basically support everything, except that it's only support printed string and UTF 8. I think that should be okay. Also tries to make optimizations. So as in general, everything is coded as an array of relative distinguished names. But if there's only one relative distinguished name, the array is omitted. The relative distinguished name is itself encoded as an array, and this was based on a comment on that we should not use map as theoretically the order of the map it's unordered. So we changed this also to an array, and if the array only contains one attribute, it's encoded as a text string. No, it only contains a UTF string encoded common name. The array is omitted and it's encoded as only a text string. And if the text string contains the EUI64, it's encoded as 8 bytes instead. And further, the specification says that if the EUI64 is created from a MAC 48, it's encoded as a 6 byte byte string instead. Here there's a lot of several issues on the GitHub created. One thing is that I think the unclear whether how the EUI64 is encoded in the certificate. I don't know if that is really specified well in some draft. We assume it's on this form where X's are hex. And if it was created by a MAC 48, you have FFFE in the middle. Then reading IEEE specifications, I just got more confused. Seems to be FFFE or FFFF in the middle. Also, both Wikipedia and IEEE says that the EUI64 encoding from a MAC address is deprecated. So maybe we should not encourage that, i.e. we should not have any special handling of MAC address. And also a related issue is that MAC address is today very much, in some cases, some environments, randomized. So basically it's not suitable to have in a certificate, but maybe it's because of that this practice has been deprecated. I think there's people in here that knows, and Karsten is in queue. Please go ahead, Karsten.
Yeah, I just ran into one of my usual little issues when you try to have an invertible encoding of MAC addresses into binary and back into text. Then you run into lowercase, uppercase issues. So I have no idea how X509 handles the case here. They probably should have some determinate algorithm for that, but I don't know. So let's check that. And of course, in general, whether MAC addresses are very useful subjects, we will have to decide this from the corpus. There is no value judgment here. It's just a question, do people use that or do they not use that? And if they use it, we should support it. And I don't think we have privacy considerations here, because if they already are using MAC addresses, then they already have made the decision not to be very privacy aware.
Good. A very good comment. I have not thought about the lower uppercase. Guess that goes back to if there is any format for how you encode a UI64 in a certificate.
I would like to answer Fraser's question in the chat. Does it make sense to have these special cases? Really, the question is who's going to do these conversions? I mean, the whole point is that the constraint device never sees ASN1, so the conversion is done on a less constrained device. And there we should have the power to add a couple of lines of code to do such a special case. So I'm generally in favor of doing encodings of really expensive text-based encodings like this 3 bytes per byte hex encoding of MAC addresses. Since MAC addresses already are not exactly small, that's probably worth it if they are actually used, and that's something that I don't know.
Yeah, this saves a lot of bytes. I think it saves like 18 bytes if you have a going from text representation to 6 bytes.
For the explanation.
Any more comments on this? I think this is something we definitely need more input on from people that know EUI64 and practices in this field. Maybe move on. So here is so this is continuation about, so we created a table and a registry for attribute types, and the proposal right now is to only support printable string and UTF-8 string, and the difference between them are signaled as the sign of the value you see here. So a UTF printable string is 1 and the UTF string common name is -1. If anybody, anything else old does not seem to support me. I guess there has not been any new inventions on how to on attribute types either since 5280 was written. Something we identify was the printable string only contains 6.2 bits of information per character. It could be compressed, but I don't know if that's a good idea. Then, for example, in TLS, you could, if this is a certificate type, you could use compression on top of this, and then compressing each string in some way would probably increase the total size, and also it makes it much harder to, then you cannot read the text strings in for example cbor.me or any cbor encoder easily. But it's just a note that there could be room for compression. Organization and identifier is that organization. Okay, so a suggestion here from Stefan's to add a new attribute type, I guess. Seems good. I add that to the list, and here it's very easy to add. Adding new attribute types, as long as they have the same encoding, it's just a registration of a new int. Okay, next slide. So validity was a comment from Jim to add generalized time as well. We have done that in the 03. Both UTC time and generalized time, the proposal is to encode them using Horner's method with different bases, as you can see the formula here on the slide. And UTC time and generalized time can be encoded. The difference, they are encoded as 4 or 5 byte, respectively. And the coding can quite easily be done by modeling and subtraction operations. Also comment from Jim why we don't use Unix time. And there is, I think that can be discussed. There's some disadvantages. One is that Unix time cannot support leap seconds, which is a part of RFC 5280. Also, when implementing, my feeling is that Unix time is not back to and from Unix time is not really well supported on all systems or platforms, but maybe I'm wrong. And also, at least in C++, one of the, I don't remember if it was to Unix time or from Unix time, made use of local time by default. So if you want UTC time, you need to add your time zone. I don't know, if you don't have it supported, implementing Unix time is a lot more complicated than implementing this. As you need to know a lot about leap year handling. The leap year handling is so complicated that Unix committee actually got it wrong for the first specification. But otherwise, the Unix time and disencoding would use exactly as many bytes. Boot representation you can compare directly with this formula. You cannot calculate differences in time periods from the compressed values that you can do in Unix time, as it's just counting the number of seconds. Russ Housley comments that 5280 requires the time to be in UTC. That is, my understanding is that 5280 requires that if you use a time earlier than 2050, and you're forced to use generalized time if you have a time after 2050. But my understanding is that that's not always followed in practice. For example, Brazil has government has requirements that you shall always use generalized time, for example.
You misunderstood my comment. The time is always in UTC.
Yeah, okay, sorry, yeah.
The format is before is whether or not the decade digits are carried or not.
Yes.
And I don't think it only carries seconds, so I don't know. I can't think of in a certificate where a leap second matters. It's just a matter of, could you reproduce the digits that appeared in the certificate so you could check the signature?
I think in Unix time you cannot, but on the other hand, leap seconds is a very small corner case and probably not used in very many.
But what matters in responding to Jim's comment is that you could reproduce the string of digits so the signature will check.
Yeah, that you can definitely do with both encodings.
Right.
Maybe if there is more discussion needed, we can move it to the list. It seems that you have a few more slides to present, John.
Yeah, let's move to the next slide.
Yeah, you have like 4 minutes just for information.
Yeah, thank you. So extensions, so this the previous suggestion had it was very limited. It was meant to be very limited. So this has been completely rewritten, and now we can encode. I think basically any certificates on the web, but of course, unless a lot of the extensions, more non-IoT extensions, are then just the integer followed by a there-encoded byte string, which is not very nice. Can go to the next slide. So here is the current Ayana registrations. We have one table for extensions, one for extended key usage, and one for subject alt names. I think these are not all the subject alt names, this was just the ones I had time to specify right now. I think we need a lot of input on what should the initial registration for these tables be, assuming we agree on this encoding. The current specification do a lot of optimization with key usage and basic constraints, basically encoding a lot of things in the integer that might not actually be worth it in the end. And I think we might want to simplify this and take 1 or 2 bytes extra encoding for encoding. Unless there are any comments, let's move.
Jag gör det.
Next slide. Okay, yeah. Next slide. So yeah, so this is just the overview of COSE and TLS. I registered everything based on X5. I thought it was easier to remove if we don't need. Change the TLS to its certificate type instead. Suggestion to coordinate this with the TLS working group, and this maybe when the COSE has adopted work on this, if COSE do that. Next slide. And here is an example encoding of the tools IETF certificate, and this was original. Their encoding is 1650 bytes. The CBOR encoding is 1374, so you save 270 bytes, but that is only 16% compared to the 56% in the very constrained certificate. And as you can see, what is marked with green here is the extensions in 7925, which we have defined CBOR encoding for the values. The other are just their encoding are taken just from the certificate. And I think this should be discussed which extension we should handwrite encodings for, or if can we come up with a general CBOR encoding that just takes the sequences and sets of ASN1 and map them to CBOR. Probably for the RFC 7925, you probably want some special handling, but for the other, you would probably be best with a general thing if it can be constructed. I think that's it. That's probably the last slide, or yeah. We would very much want more reviews. People trying to implement this. I have implemented DER to CBOR, which supports a large part of this. The plan is to try to release that as open source in the coming months. I will write to the list when that happens. And then, of course, more discussion on the list.
Okay, thank you, John. So I think we are approximately right on time. So thank you everyone for your participation. If there are any questions and comments, please give them on the list. And yes, see you around. Have a nice day.
Thank you.